that we're going to be dealing with in this section are going to come back to this sort of basic idea that if you want a percent of a number, you just multiply the percent by the number. And that's that we can kind of clean that up, or rather we can write that mathematically as an equation where we have some base amount given, a base number given, and if we multiply that by a percent, then we get some amount. And this is going to be helpful for problems where you're asked to find a base number or find a percent, because probably most of us, if we're asked to find the amount, once you learn how to multiply the number by the percent, then it's relatively easy to figure out these problems. But the problems where you're trying to figure out, okay, I don't think I'm looking for the amount now, they're asking me to work the problem in reverse and find the base instead, or maybe even they're asking for me to find the percent instead, then it's helpful to have this idea, or this relationship, this mathematical relationship between these numbers written down. And you can read this in words as base of, actually, it would be more comfortable to read it this way. Percent of base is amount. So that's the of being to multiply. And of course, it doesn't matter what order we multiply, right? I can swap this around and put percent times base equals amount. Percent of base is amount. So we'll be using that a fair bit. Okay. So let's suppose that we want to figure out how much our tip should be at a restaurant, and we're going to calculate different percentages given some fixed bill amount. So let's suppose oh, how do you spell restaurant? What a hard word to spell. Did I spell it right? Anyways, I didn't. The U goes here. Whatever, who cares? It's not spelling class. Suppose our bill at a restaurant is, let's say, what should I say it is? What's a sort of normal number, like $27.62. And I'm not enumerating this with an example because this is, I'm going to do a lot of weird stuff with this example, and then or with this this example we're doing together. And then for example 1, I'll give you guys a chance to try it. So if we wish to tip 10%, so we're being cheapskates and we're only going to tip 10%. If we wish to tip 10%, how much will the tip be? Okay. Well, what we want is 10% of that number, 2762. We want 10% of that number. So we're going to multiply. We're going to multiply. But we need to recall that when we multiply by a percent or divide by a percent or do any math with a percent, we should convert it back to decimal form. So what we really want, well, let me write it in a different font here. We want to know 10% of 2762. So all we have to do is take 10% and multiply it by 27.62. In other words, take 10%, which as a decimal is 0.10, and multiply it by 2762. Let me get a better red marker. And by the way, how do I know 10% is the same as 0.10, 0.10 there? You can just take 10% and convert it to fraction form, just recalling that 10% is the same as 10 over 100. Any percent is a whole number percent can be written as that number over 100. And then, of course, 10 over 100 is, you just plug that into the calculator to figure out what the decimal representation is. But of course, that's just 10 100ths, which is exactly how you read this decimal, right? It's 10 hundredths. Okay, so then doing this multiplication is going to yield 2.762. It just scoots the decimal point, right? It just scoots the decimal point to the left by 1. And then when we round to the nearest cent, because we're dealing with money, right, that will be $2.76. $2.76. Okay, what if we wanted to know, so now if we tip 20%, which is more of like an acceptable rate, especially here in America where servers are literally paid like $2 an hour, right? So if we tip 20%, how much will the tip be? So if you've got the intuition for what's going on here, you're probably thinking, well, that's 10%. And I want to do 20%, so can't I just double it, right? Can't I just double it? Well, the answer is yes, but let's see what happens when we set this problem up the same way that I just solved the 10% problem. So I'm going to say first, so it's the same bill, right? We want to find 20% of 2762. That's our bill. In other words, we're going to do 20% times 27.62. Convert the decimal, or rather, sorry, convert the percent to a decimal, so 0.20 times 2762. And then plug that into the calculator. And what do we get? So 0.2 times 27.62, and we will get double that 276 back here. Well, first, before I round it, we get 5.524, which then I'll round to be $5.52, which is exactly double the 10% tip. Okay. So yes, if you're thinking, could I just find 10% by scooting the decimal out by 1 and then just doubling it? Yes, that's a legitimate way to do that, especially if you're trying to do this in your head. If you're trying to do this in your head, and you see that amount, 2762, all you have to, if you want to tip 20%, which is like standard, right? You scoot the decimal out to the left 1 position and then double that number. So 276 times 2, and if you're just doing it in your head, 276 times 2, you could say, all right, that's between $5 and $6. So if you left $5 or $6, that would be, an appropriate amount to tip here. Okay. All right, now let's do an example. And I'm going to get a little bit more creative here. Okay. Let's see. No, I need to do that after we talk about taxes. Okay, so let's suppose your bill. So never mind. This one's going to be kind of the same, and then we'll talk about sales tax, and then I'll put together a more complicated, more involved example. But let's just start with baby steps here. So suppose your bill is, let's say, I don't know, $48.49. Okay, so this question is different from the one I just gave you because I'm not asking straight up for the tip. I'm asking for the total. So of course you're going to have to find the tip and then do what? You're going to have to add them, right? So there's a couple different ways you can go about this. You can use sort of the more intuitive way where you just find 10% of this number and then double that, right? So scooting the decimal point out to the left by 1 and then doubling that. Or you can just go straight for finding 20% by setting it up this way, 20% of 4849, which is the same as 0.20 times 4849, and finding it that way. So just kind of trusting the math there, getting 9.698, which if we round correctly to the 100th place, because we're dealing with currency or US currency here, so 9.70. Okay, that's not the answer to this question though, right? Because we want to know the total. The total is going to be that 48.49 plus the 970. Which should be 58.19. So we're getting total of $58.19. So what are some things to point out here that aren't exactly real world? Well, you probably wouldn't leave a fractional tip, right? Like you're not gonna like get out your quarters and dimes at the Applebee's, you know, to put down your tip, right? So, you know, in this case, you would probably round up to $10, just to make it, you know, I mean, unless you want to be super precise and give them exactly 20%, you know, so then you can bust out the pennies and nickels and quarters and dimes, but maybe that's something that's not exactly real world here. Because most people just leave whole number tips, right? Cash, not cents. Something else I want to point out here is there is a quick way to do all of this in one step, and that is to consider that if we're leaving a 20% tip, then how much are we paying relative to this bill? If we are leaving a 20% tip, then we are paying 120% of, like in the end, with the tip included, of the 48.49. Right, because a tip is adding to your bill, right? It's adding to your bill. And this is the same as like sales tax. I'll make the same point when we talk about sales tax in the next example. So what does this mean though? Like how can we use this? Well, then we want 120% of 48.49. Oops, 48.49. And how does that look? 120% of 48, well, that's going to be 1.20 times 48.49, right? Just writing the percent as a decimal. And that would end up giving us that total. So if you want to do it all at once, you just stack that percentage onto 100%, because 100% of 4849 is just 4849. So you're taking that total, or rather that bill, that 4849, and you're adding the 20% on up front with the percents, instead of finding each percent individually and then adding them. You're doing it all at once here. Cool. That tends to be a very useful technique in this section. Okay. So let's suppose, let's talk about sales tax. So that was tipping. Let's talk about sales tax now. And this book is old because it's citing, the book I'm following through, our book, is citing sales tax that are a lot lower than they currently are. Let's see when this book was published. Well, if I can find it. Oh, 2016. It's not that old. All right, well, anyways, let me make a note. Sales tax can be calculated very similarly. I'll say in a similar way, to tips at a restaurant. I'll just say tips can be calculated in a similar way to tips. And what do I mean by that? Well, because it's definitely a different thing, right? But in both cases, you're taking a bill and you're adding some percentage to it. So for instance, let's go straight into example 2, because the math is going to work out the same here. So suppose we're buying a TV that has a sticker price. So sticker price does not include tax, of course. A sticker price of $499.99. Let's say you're buying it in Oxford, where the sales tax is 10%, I think. If the sales tax, in fact, I think it's 10% in Oxford, Jacksonville, and Anniston now, I think. If the sales tax is 10%, what is the total cost of the TV? Okay, I'm going to solve it the same way I solved the example 1 by putting those percentages together. So the way I did it on the side here in blue. So I'm going to add the percentages together. 100% is going to just represent the actual sticker price. And then I want to add 10% because that's how much the sales tax is. So I need to know, or I'll say we want to know, 110% of $499.99. Okay, that's the same as 110% is the same as 1.10 as a decimal, just dividing it by 100, right? Just take your percent, divide it by 100. That's all you have to do to figure out what it is as a decimal. So that's the same as 1.10 times that amount, sticker price here, $4.99.99, and that's going to give me, so 1.10 times 499.99, 549.989, so 549.989, and then of course if I round correctly, I'll get, because I want to have it as a dollar amount, right? So I'm looking over here to round those. Oh, dang it. To round these cents, I know I want to go to the 100th place because I'm dealing with U.S. currency, and since this is an 8 and the digit before it is a 9, that tells me to round up. So, long story short, it'll be 549.99. Okay, so it added about $50, which makes sense because this TV basically costs $500, right? I mean, it's 1 penny off of $500. What's 10% of $500? Well, it's $50, right? So we added about $50. Exactly $50, really, when you round. You added $50 to the cost of the TV for sales tax. All right. Now you could do this individually. You could find 10% of this and then add that to the base price there to get this new total. Okay. Let's do an example where things are a bit more involved. All right, let me set the stage for you here. So let's suppose, quarantine is over and, you're starting to go on dates again, right? Got all these Tinder matches and finally you're able to go out to the Applebee's and get some dollar margaritas or whatever. So let's suppose you've got $30 in your wallet in cash and you have nothing left on your debit card because you're not getting paid until next Friday, so there's like 80 cents on your debit card, so, and you've got $30 in your wallet for this date. So suppose you have $30 cash. So you're on a date at a restaurant. I'm just going to say Applebee's because that's the only restaurant I can think of off the top of my head. So let's say your entree costs, let's see. Let's say you've only got $30, so you're trying to be cheap. So you got the chicken tenders. Your entree only costs $10.99, and your date entree costs. Let's say he or she went for something a bit more expensive, like that weird bacon mac and cheese stuff they have at Applebee's. Let's say it costs $12.99. Okay. You get a water, so your drink cost is $0. But your date's drink costs $1.99. They got some flavored tea or something. Okay, what next? You know that sales tax in Oxford or wherever you're at is, let's just say 10%. how much money are you going to have left? So we're assuming you're paying for the bill, right? How much money are you going to have left after paying the bill with sales tax included how much are you going to have left after paying the bill with sales tax included to leave as a tip? Okay, so there's the problem. I'll give you a second to write that all down. And then I'm gonna get you guys involved. I'll call on some people here to answer some questions because there's a fair bit to do here. All right. All right. How about Isaac? What do you think we should do first? Like, what should our plan be here?
I suppose add all of the totals, not the totals,
Yes.
but all the costs together.
Yes, I think that's so step one, let's step one will be to find total, I'll say it this way, total before tax. Right? And then step two, let's see, Abbott, what do you think step two should be? So we're going to have, in step one, we'll have that total before tax. So we'll have the entrees and the drink cost added up, and we'll have some dollar amount. What should step two be?
You would multiply your sales tax by the total.
Yes, so I'm going to be even more vague here. That's right, but I'm going to be a little bit more general and say I'm going to say find total after tax, which is what you described. That's right. Good. Okay, and then so step two is assuming I'm finding the tax, that 10%, and adding it back to whatever the total was here. So I'm going to have some amount with tax included, and then let's see, how about who else do I see here? Aja, what do you think would be the last step? So at this point, you would have your total after tax. How about
I
chat?
can't
Oh,
see the.
yes.
I can't really see the whole thing.
Right. So after we find the total after tax, what would be step three? So I'm not asking you to calculate it, just like what would be the next step. So we found total before tax by adding up all these costs, and then we're going to add in that 10% sales tax, and we're trying to figure out how much money you would have left after paying the bill with sales tax included. So what would that last step be? What do you think?
Finding the overall total.
So we would have that already, and then since you have $30 and
I think subtracting the final total from the 10%.
from the $30, right?
Yes.
Yeah. So we would say we would find, let's say it this way, find amount, thank you, left over. Well, how should I word this? Find amount left over from the $30 that we're bringing, and that was from a different problem. Okay. So we have our plan now. And you're thinking about this all in your head as you're on this Applebee's date, and you're like frantically like trying to whip your phone out in the, under the table to like do some calculations or something. So let's see what's going to happen. Are you going to have enough money to leave? I don't really have room to do this, so I'm going to rewrite relevant information. Are you going to have enough money to leave a tip with your $30? So step one is to find the total before tax. So I'm going to add up your entree. I'm going to drop the dollar signs. They're not necessary right now. Your date's entree, your drink, which was 0, so don't really need to write it, but there it is. And then your date's drink. And you didn't get any appetizers, thank goodness, right? Probably couldn't have afforded that. And you didn't get any like mixed drinks or desserts. So add these up real quick. 10.99 plus 12.99 plus 1.99. I'm getting 25.97. That's not looking good so far, right? That is just step one. That is the total before tax. So that's step one here. Step one. Okay, step two is to find that total after tax. So what we can do is I say, all right, I know the sales tax is 10% here. So I want 110% of 25.97. That's going to be the same as 1.10 times 25.97. And that's going to equal, so 1.10 times 25.97. Why do I keep picking 10%, by the way, for the sales tax percentage? Well, because that's just where it is, where we live, right? So obviously it can be different in other places, right? Okay, so I'm getting, as I round correctly, I can put dollars on the end result here, $28.57. Now, last step is to find the amount left over that you're going to have left to have a tip, which, as Aja told us, we'll subtract from that $30. So we'll say 30 minus the total bill with tax included. And this is how much we're going to have left over for a tip. $1.43. Oof, that's, let me ask a follow-up question. Because like you're thinking, you're calculating this, and you're like, dang, I'm only gonna like $1 and some change to leave as a tip, So you're thinking, what percentage is that? Like, how much of a cheapskate am I gonna look like? So let me ask a follow-up question. What percentage? Hang on a second. When you tip, oh my gosh, I haven't been to a restaurant in so long that I've legitimately forgotten that when you tip, do you calculate your tip from the total before tax or total after tax? I've legitimately forgotten.
You tip based on sales, not your tax.
Okay, that makes sense. Yeah. Uncle Sam has already taken his cut here. So yeah, all right. So we'll go, what percentage of 25.97, which is that total before tax, is that 143? So like, it's not 20%, right? That, like, just intuitively you're thinking it's lower. But what percentage is it? How could we figure this out? Well, remember that equation I gave you up top in the beginning of this lecture that I said would be useful, which I have now lost because my notes are all in a mess. It is base times percent is equal to amount. And here I'm asking for the percent. And how do I know which one is the base and which one is the amount? Well, because of the structure of the way I've written my sentence, I know of is it means to multiply. So this number 2597 must be over here attached to the percent by multiplication. Also, I see that it corresponds to the equals, right? So this number is 1.43. That should be isolated over here by itself on the other side of the equal sign as the amount. So what I'm saying is I'm going to have 25.97 times some unknown percent is equal to my amount. These are probably one of the hardest versions of these problems to solve. How do we solve this? Now that we've got it written as a mathematical relationship, you can fall back on just pure like algebra, right? How do you isolate something in an equation? You get rid of stuff attached to it. How do you get rid of the stuff attached to it? Well, it depends on how the stuff is attached. Since this number is attached via multiplication, I'll divide both sides by that number to isolate percent. I'm trying to look for percent, so I'm going to divide on both sides, which is fine. I'm going to get a very weird tiny decimal number, but that's okay. So on the left-hand side, it just cleans up, giving me just percent, right? Successfully isolated percent. Now I've got to figure out what's going on over here. So I'm going to do 1.43 divided by 25.97. And I'm going to keep 4 decimal places here. 05506, so 05506, so I'd round to 1. But I want this as a percent, right? This is a decimal form of the percent. How do I get it back as a percent? Well, recall to go from percent to decimal, you divide by 100. So to go backwards, you'll multiply by 100. So I'm going to get across here, I'm going to multiply by 100 to get it, well, really 100%, because I'm going to add that percent symbol on the back. And I'm getting that this would be 5.51%. Okay. So what just happened? You were on a date at the Applebee's and you only had $30 cash in your pocket, and you're trying to figure out, based off of your entree cost, your date's entree cost, and your drinks, and then tax, how much would you have left over for a tip? And that's it. And then I asked a follow-up question of what percentage are you leaving? You know, because we know 20%, is like standard. So how much are you leaving by leaving this, by basically leaving all your change, 143, and you're leaving about 5.5%. So what's the moral of the story here? Well, I don't know. Just bring a little bit more money to Applebee's, I guess. Yeah. Cool. So that's kind of putting all these ideas together, which I think is kind of fun. Maybe not. Okay. Now let's talk about sale prices. Oh, well, are there any follow-up questions or anything about this, or any comments? There's a lot going on there, so any questions or comments about this particular problem? Okay. I miss Applebee's. The food isn't even good, but those dollar margaritas, man, it's okay. So let's talk about sales price now. So the two problems we just looked at with calculating tip and calculating sales tax, you're adding onto your bill. What if you're subtracting from your bill with a sale, like something that's on sale? So let's suppose, actually, I'm just going to go ahead and write this into an example, because the math honestly is not much different. Just where you add, now you're going to subtract. So suppose you are buying let's say a sweater for let's see. Suppose you were buying a sweater that originally costs $45.99. If the sweater is on sale for 40% off, how much does the sweater cost? I'm going to ask a follow-up question for this one too, but we'll just start with this base question. How much does the sweater cost? Or how much, yeah, that's fine. I could say how much will you pay at the register or whatever, but that's fine. How much does the sweater cost? And we're ignoring tax here, right? Because you would still pay tax on this, but you're just kind of isolating the percent off, the 40% off part of the problem. Okay, so what are we going to do? We're going to say we're going to find 40% of $45.99. So we want 40%. And if you're thinking, well, what about that shortcut we used last time? Is that legitimate to do here? Like how we stopped finding the two pieces individually and then adding them together. We just found like 120% of the number in the last problems. Is that going to be a legitimate thing to do here? Yes, but I'm going to do it in two steps first. 40% of that, $45.99, so times 44.99. I'm assuming we're good with the converting the percent to decimal. This would just be 0.40 times 45.99. I'll write it down anyways, so 0.40 times 45.99. Going to give me 18.40 when I round right. This gets subtracted from my total because it's a sale, right? This is a sale. So whenever you're thinking, like when you reach this part of the problem and then you're like, oh, am I supposed to add or subtract? You have to step back from math class and just read the problem like a consumer, right? And say, oh, it's a sale. It's a sale. So this should be, better not be added onto my total, right? It's taken off of the total. So now I'm going to do 45.99 minus 18.40. And I'm just going to use a calculator for that. And I'm getting 27. There we go. That's what you would pay before tax. You would still, how much would you legitimately pay at the register? Well, that would depend on what the sales tax percentage is, but just for 40% off of the sticker price would be about $27.59, or about $28. Okay. Now, can I do this all at once? Yes. Because 45.99 represents 100% of the cost of the sweater, right? 100%. If the sweater is on sale for 40% off, how much are we going to pay? We're going to pay 60%, right? So I can just sum all of this up into one step and say I want 60% of 45.99. By taking 40% away from 100%. That's how I got 60%. And then follow the math through, see where it takes you. And it's going to take you right back to $27.59. So that shortcut technique we used last time is legitimate here as well. It's just that instead of adding the percentages together, you're subtracting the 40 from 100. Okay. Now, I want to ask a follow-up question here. Well, are there any questions about that? Are we all good with that? Okay. Okay, I want to ask a follow-up question, which is have a coupon No, I don't really think coupons are traditionally used for like buying sweaters, but maybe if you have a coupon for an additional 10% off, would you be wrong if you okay. So still the same example, just a follow-up question. So you have a coupon for an additional 10% off. Would you be wrong if you just assumed, oh, that means I have 50% off? Because you know it's 40% off and I got a coupon for 10% off, and you're thinking, yeah, that's fine, right? But it is wrong. It is wrong. Why is it wrong? Because the company is not going to take that 10% coupon that you have from the total. Let me explain. This is wrong. Why? Okay, consider this. Consider what you are assuming is that they're taking that additional 10% off of the total again. You are assuming they will take 10% more. You may not have known you were making this assumption, but this really is what you were assuming. They will take 10% more off of $45.99, which would be, by the way, for 60. Just finding 10% of 45.99 and rounding correctly, it'd be $4.60. But they're not going to do that. Where do they take? So by the way, how is that the assumption being made here? Well, because you're assuming the 40% off, which is legitimately off the total, and your 10% off coupon are coming from the same number. Does anyone know what would actually happen, or any insight into this at all? Yes, go ahead, Stephen.
You have to take the initial 40% off first, and then before tax, that total before tax with the 40% off, you subtract another 10% off of that.
Right. Yeah. Exactly.
And after tax, and then that's your total.
Exactly. So it's what's going on is that we're assuming in this situation, by adding those discounts together, that they're taking 10% off the original total, but they are actually taking 10% off from that amount that we found a second ago, that 27.59. And why does it matter? Well, that's a smaller number, right? So 10% off of that is going to be a smaller discount. And I'll explicitly write it for you here, which would be 2.76. Look at that. That's a smaller, compare those discounts, right? They're going to do what they can. If you're like stacking coupons, they're going to do what they can to only give you the amount, well, to give you the least discount, right? Of course, you know, they're going to try to give you the least discount. And the way they do that is if you've got coupons that you're trying to stack, or sales discounts that you're trying to stack, they do not just add up, right? You're going to continually take percentages off of the new total, which would be a smaller number, giving you a smaller discount. So what would you actually end up paying here? What would you actually end up paying if you had the 40% off, which would give you this $27.59, and an additional 10% off? you would subtract these two. So actual total after additional 10% off would be, whatever the difference between these is, 27.59 minus 2.76. Which would be 24.83. Yeah. And then from here, then you would add your sales tax and everything. Oh, another question. Then would your sales tax, if you assume sales tax is 10%, would that just bring you back to 27.59? Well, no, it wouldn't, right? Even though you're subtracting 10% and then adding 10%, but the 10% are coming from different numbers, right? 10% of this number subtracted is giving you this, but then 10% of this number added back onto it, the 10% would come from this number now. So it's all, percents get a little wild sometimes because you have to know where the percent is coming from, right? So that's just something to keep in mind, helps you be a smarter consumer, right? Now, a lot of this stuff is automated nowadays, like your cashier is not actually calculating this stuff, right? It's all automated. Also, a lot of places don't let you stack coupons anymore, right? Because of this kind of shenanigans going on here. So, but so everything's automated, but still it's good for you to be an informed consumer and to know what's going on behind the scenes. All right, that's all I got for y'all today. Next time we'll finish 4.4, which we'll talk about percentage increase and decrease, and then we'll get into chapter 6. So that's all I got today. You are all good to go.